Welcome back to Math 103. This is video number 31 on growth and finance. Suppose that you know how much you need to borrow right now, let's say $30,000, and the annual interest rate is 12% compounded annually. If you make annual payments beginning 1 year from now and ending 15 years from now, how much should each of your annual payments be? We could go ahead and start substituting values that we know into our formula and solving for the value of PMT. That would be a fine thing to do. First, I want to make sure that we understand how this problem fits into our earlier framework, our earlier narrative, about how the amount that we borrow today, that's $30,000, is really a sum of smaller amounts. Each one of those smaller amounts corresponds to one repayment that we're going to make in the future. Bank number one is going to loan us a certain amount of money today because we're going to pay back a certain amount PMT 1 year from now. Bank number two loans us a little bit less than bank number one, also based on a payment of a certain number of dollars, but 2 years from now. That goes all the way out to bank number 15, which is going to lend us a certain amount of money today based on a payment of that same dollar amount PMT, but not until 15 years from now. It would really be a nuisance to compute all this by hand and solve for PMT. We rely on the formula. We plug in 30,000 for PV, our known present value, the amount we borrowed today. 0.12 equals I, so 1 plus I is 1.12, and there are 15 separate payments from 1 year from now through 15 years from now. Now we compute our way through the formula. $30,000 equals PMT times 1 over 0.12 times 0.817303739. So we have to be a little bit careful computing that value. Sorting this out, we find that PMT is multiplied by 6.8, etc., etc. So we find PMT by computing $30,000 divided by this factor 6.8 something. So just a comment here, just to lend some insight so that this isn't just a mystery, what's going on inside this formula. This 0.12 is the interest rate as a decimal. If this number were smaller, then dividing by it here would produce a larger number right there. And if this number is large, then after dividing at this stage, we'd get something small here. Right? So if that 0.12 were smaller, then this number at the end for PMT would also be smaller. The larger the interest rate is, the larger the payment is. All right, so PMT turns out at the end of the computation to be $4,404.73. That's how much your annual payments will need to be, starting 1 year from now and continuing until the last payment 15 years from now. Is that annual payment a large amount of money, a small amount of money? How can we tell? Let's think of it this way. At $4,404.73 per year, for 15 years, the total amount of money you'd have to pay back would be $66,070.91. You're paying it back over the course of 15 years in exchange for the opportunity to borrow $30,000 right now. That's the trade-off. This is painful. Think about it. You're ending up paying a total of this much, $36,070.91 in interest. That's the total amount that you pay back minus the amount that you got handed to you at the beginning. That difference is the interest. That's what you're paying in exchange for this opportunity to borrow the $30,000 right now. You can think of it this way. This is how much profit the bank makes, roughly speaking. This is the extra amount that you're paying back over and above repaying the $30,000 itself. All right, so you're paying back more in interest than in the original principal borrowed. What's the moral of the story? There are several morals of the story. One of them is, don't be in debt. Another moral of the story is, 12% is a very high interest rate. Part of making decisions about borrowing, whether to borrow and how much to borrow, depend on how high the interest rate is. So 12% a year is very high. Try to avoid it. Working out these details of a 15-year loan, as we just have, leads to an important follow-up question about the pros and cons of paying off the loan more quickly. Before going on to the next video, answer the following questions. Suppose that you need to borrow $30,000 right now, and the annual interest rate is 12% compounded annually. Same story as the previous problem. If you make annual payments beginning 1 year from now and ending 10 years from now, the last payment is 10 years from now instead of 15, how much should each of your annual payments be? And how much interest in total will you end up paying over the course of the next 10 years for this loan?